Esto fue hace años. Yo hace años intenté aprender Kubernetes, pero tenía muy poco tiempo, así que no lo pude hacer. Kubernetes es una weá que controla muchas imágenes de nuestras aplicaciones en unas cosas llamadas Docker, que son como, imagínenselo como un barco que contiene muchas cajitas de algo. Y estas cajitas de algo, son réplicas de la aplicación. Son réplicas de la aplicación, ¿cachai? Y estas réplicas de la aplicación se van mandando a diferentes lugares. Y cuando se cae una por mucho tamaño que tiene la cuestión, o sea, por mucha solicitud o cualquier cosa, y llega la otra, entonces la página nunca se cae. Veamos acá un full curso.
Hi, my name is Chad, and this is your Zero to Hero Kubernetes Fun by Kubernetes. etcd was around long before Kubernetes was. And what is etcd? It is a strongly consistent distributed key value store that provides a reliable way to store data. $1,000 millicore. What the heck is that?
Mira, como pueden ver acá, este es un tipo de... Este es el archivo de Kubernetes, que aquí uno le sale cuánto le quiere dar a cada guaita ¿cachai? De los contenedores que les mencioné.
Get out. That's what I want to be my little welcome page, right? Environment, well, call it environment variable, put the keyword value from literal. So from literal is something you can use also when you're making config maps. Just makes it easy to put key value pairs inside of objects. But we won't be doing that. Let's just go ahead and create this secret from this manifest. And let's make sure that it's saved, otherwise that won't whatsoever. We're going to go ahead and create this pod. And I want to show you that if I were to type kubectl get pods -- show labels, it'll give us the typical get pods output, but now there's also this column, labels, none. You can see we did not put any inside of the manifest. First thing we need to know is how to change, update, or remove labels on our pods and other objects. So let's just get a little stream going so we can see this update in real time. There we go. First method is to go and edit the actual manifest itself. So under metadata, labels, remember labels are definitely always key value pairs. So cool beans, that's what I want to do. If I do a kubectl apply, that's a totally legal change. Kubernetes is happy to make changes to running pods. And as you can see up,
los contenedores que le dije son pod, son llamados pod, como dice acá el tipo.
There, it's got.
Por ejemplo, aquí dice spec, un container con el nombre com y la imagen de Nginx, que Nginx es un servidor. Creo que es de Javax, sí, que si no me equivoco.
Label cool beans on it. But there are other ways to add or even control scale. The other thing that I want to show you that you can mount a config map to multiple pods. You can mount storage far. Now, suppose that I'm making a change. I want each of those pods, all 10 of them, to not have one container inside of them, but 2. And let's just say that, I don't know, we want to put like a Redis image inside of it. It doesn't really matter what the image is. But the point is, you cannot add new containers to pods that are already running.
Hola, hola.
So this will be a good demo. Now, I want you to watch very carefully on what happens when I hit enter here. You're going to see a second replica set appear. You're going to see the number of available pods for that replica set go up, and the number of pods for this replica set will go down, because that's that rolling update that I was telling you about earlier. So there it goes. One is increasing, one is decreasing, effortlessly flowing from one to the next. Boom, done. So all 10 of those pods have been recreated, and now all of those pods have the 2 containers inside of them, as you can see right here. But here's what's super sexy about deployments is that you can not only roll out changes, you can roll back changes. So what I'm going to do is I'm going to use a whole new command here to control rollout history of our deployment called demo deployment. This history keeps track of how many revisions has this gone through. And there's lots like this. All right, now if I want to, then who's the kid who's getting parented? And what we're doing here is we're using match labels, just like we did with deployments. Like I said, labels are so important in Kubernetes. And basically, the way this works is that if you are in the default namespace, and if you have the label role DB, you are about to have your traffic coming in and coming out controlled and certain criteria.
Estamos aprendiendo acá Kubernetes. Kubernetes es un tipo de coso para controlar imágenes de aplicaciones en internet. El ingress es la URL. Las labels no me acuerdo, pero me dijo que era importante.
It has to be met. All right, so let's go on down to the bottom part. Here and here is where we're going to be setting up what are the rules that have to be followed in order for traffic to actually work. So for ingress, here we're making our first list of rules. We're saying that traffic has to come from one of the following sources. Now, you don't have to use all of these. In fact, most folks won't. But again, this is the longest and dirtiest example that I could find, so we'll just go ahead and use that. IP block allows us to specify a CIDR range of IP addresses. Like, it's got to be that pod in this range, otherwise we're not going to allow that pod to send ingress. Except, and you can advertise exceptions, if it's in like this range or this particular one right here, that it's going to be not allowed. Pods can talk to each other across namespaces, which is interesting. So even if pods are in different namespaces, if one is exposed by a service, it's not safe. Other pods and other namespaces can access it. So namespace selector is where we can say that, hey, pods in the default namespace, making 3 identical pods. 2 of those pods happen to be on node 2, and 1 of those pods happens to be on node 3. That's just...
Chau, yo igual me voy a retirar ya. Gracias por mirarme, gente.